Hello, welcome back to PageKey Tech, where we are streaming yet again, attempting to get VGA working. So this is not going the way that I thought it would. Let's just go through real quick. I have some notes. I have some different things that I tried. You can see here that I used GDB to go in and dump the value of every single register, every VGA register before switching into VGA mode and after. And no matter what I did, even if I restore these exact values to exactly how they were before, using the methods that we set up in previous videos, it still does not actually work. So something is going wrong here, and I've noticed that it has a lot to do with the sequencer registers. In particular, these two guys here seem to really wreak havoc. If you're going to set the map mask in the memory mode in the sequencer, it doesn't seem to like to go back. But unfortunately, that's also essential to getting the little tiny pixels that we need to actually, get some good color and drawings on the screen. So I started adding some notes, and right now, today, I guess I'm going to change my approach, because my mental model of this was that VGA, the card just has a bunch of registers, and it's just a state machine. It's a simple, you change these fields to these values, and you get this result. But it would seem, actually, after playing with it a little bit, that setting some registers over here in the sequencer or in the GC or whatever causes a whole bunch of other register values to change, which kind of blows my mind. But I guess working with hardware is a little different than working with software, so I can't really make that assumption, unfortunately. So let's continue and see what we can do. So I started trying to write the article, but until we get this fixed, there's no point in writing any blogs or anything. But so let's go along and figure this out. So what else did I do? I added some, I just changed, the only change really here is I added this VGA config.c, and it's kind of a roll-up of all the other configs. This was playing into my state machine mental model here. I figured, all right, let's just roll all these fields up into one big object, and I will just set the VGA and get the VGA. So actually what I was trying to do was, you can see, or did I delete it? I might have deleted it. Right here. So this is what I was doing before and after. I would just declare the VGA config, fill it up, and save it in a variable, and then afterwards reset it back to that value. So that didn't work. So it's back to the drawing board. What can we do? What can we figure out? Let me go into my, I'm just going to put all of the, I thought that I had some notes here. Let's pull and see what we got. Okay, there we go. Now we have some notes. So in our VGA notes here, I started thinking about the BIOS, how it has mode 13H. So maybe the BIOS, since we can't rely on the BIOS, but maybe there's an implementation of the BIOS out there, or maybe there's some information on what it's actually doing. So it talks about chaining, unchaining, all that stuff. And that led me to look at, here, let me reorder this actually. 13H research led me to this Open BIOS implementation on GitHub, which maybe I'll come back to this, but I'm just kind of giving a hand waving of the different sources that we have to work with here. So this is doing similar things, right? We're outputting to the sequence registers and all this stuff. So in theory, we could go reverse engineer this and figure out what's going on. And also the QEMU documentation tells you that we have this Cirrus VGA card, like it tells you the exact model of the VGA card. So I was able to Google and find a PDF that is the specification, or the technical reference manual for that card, which is probably heavily used by the QEMU folks who made that happen. But it describes every single register and what it does. Notably, so if you go through here, introduction, whatever, it goes through lots of details about the cards. Interesting. You can look and see how interconnected all these things are. Well, this is a block diagram for each of the controller pieces. So the sequencer, how does it work? Look how everything feeds into the sequencer. You have the GC feeding in, the CRTC feeding in, and then that goes out. So pretty interesting. A lot of this is just way over my head, but it's cool to see all these block diagrams. Okay. Maybe I'll come back to that, but data block. Okay, so you have a data sheet. Okay, you keep going, and you have lots of hardware information. Lots of things that are out of my wheelhouse that I don't understand. And okay, we have more block diagrams, more data sheets, cool stuff. Keep going. Then we have the register port maps. We're getting into some good stuff here. Here we go. Look at this. You have register names, you have IO port and index. So it has a whole listing of everything, and you can click through to get to information on particular ones. And there's some extra info in here about things that I don't quite know what they are. I think they're a little beyond the basics. There's stuff like BLT something, but the core registers, like these look familiar, right? We have the miscellaneous register, we have the feature control, we have sequencer registers, we have CRTC registers, we have graphics controller registers, attribute controller registers. So they are all documented here in great detail, in greater detail than that one website. So that's pretty cool. So let's find one that's maybe interesting. So each bit is explained, which is fantastic. So if we're wondering what the values of these registers mean, this will tell us for sure. So it tells you what the pixel mask is and how it works. So there's a lot in here, and this might come in handy. So sequencer reset. Oh, okay, so that's useful information that I just stumbled across. These bits are for compatibility only, never to be used. So really, these should always be 1 for this particular piece of hardware. Good to know. Miscellaneous, full bandwidth. So should probably be a little bit more careful not to be setting these reserved bits. But to be fair, I'm getting the value first and then just changing the bits that I care about. So that should be okay. But who knows? Maybe I'm completely wrong. Either way, that's that. So we have a very in-depth manual. Oh, 9.14.3. So if you keep scrolling past all the registers, I'm going to go way down. There's a really long document. Lots of detail. Lots of registers, that's for sure. 9, we're looking for 9. So you got to get past all the registers. Still in the registers. Still in the registers. Well, I guess they have this little scroll bar here that I can use. Let's do that. Oh, 9, what was it? 9.3, 9.14.3. Let's get to that. Lots of interesting like explanations of, I guess it has support for Windows. This card has support for like recording video in the hardware. I don't know how that works. Double buffering. Wow, this is all way over my head. What was that thing? I just saw it somewhere. Something about split. I don't know. Zooming. They have some fancy equations. You know, lots of stuff going on. But what we're really interested in is. Oh, we got to keep going way down. Oh, here we go. So they start having code samples towards the end of this manual. Cursor, I could care less. Cursor, who cares? What else we got? Cursor, still in the cursor. So not, all right, PCI stuff, whatever. Continue. And then BitBlit. Oh, that's the thing that I didn't know what it was, but interesting. I don't know what it's for, but they talk a lot about it. Seems like some extra feature. Setting mode 3. This is huge. Example program to demonstrate setting VGA controller for text mode. So this is big. This is very useful. I wonder if there's a way I can copy a link to that. Nah. But basically, so unfortunately, I'm wondering if this is where that code snippet came from at one point, because they're using the same technique where they're just setting a long list of registers. And then there's another big blob of text, which I think might be the character set or something, but it's not labeled. And I don't want to just have blobs of hexadecimals in the code that I can't explain, I don't know what they are, whatever. That's not cool. That's not going to work. So they have a similar approach with the set reg, get reg, and then update attribute. So they kind of have a similar code layout, which is reassuring. And then they have some loops to set the registers. They have a RAM test, whatever that is, and then they have the main. And they are, so this might be very useful, actually. And this is right from the manufacturer. So what are they doing here? They are, we could look up what actual port that is, but they're setting synchronous reset, select clock, deassert, async reset, standard video registers, video memory test. They do it again. I don't know what's going on here. Fill the font. So that must be font up there. So this is cool, I guess, but see, got to figure out what all these are. Like if you plotted these, would they be numbers and letters? I don't know. So it's a good resource, but I don't think it's going to solve our problem. Now, the Linux kernel maybe could be a useful thing. And actually, it's kind of exciting to think about the possibility there. Let me just make sure this is still working. Yep, looks like it's working. Stream looks good. Okay, so anyway, yeah. What does the Linux kernel have to say about this? So we have a header file, and they have a similar approach where they have, this is actually the first time I'm looking at this in any depth. So they have the CRTC DC data color, data mono. So they have all the same registers defined. They have graphics enable. They have, so they just went for lots of registers, no structs or anything crazy. Although I think there's a struct down here towards the bottom. Oh, so they're using a technique of, I think when the I/O ports for data and address are right next to each other, you can just out a 16 to one of the registers and it'll hit the even and the odd or whatever it does. Kind of fancy, I guess. So interesting. So VGA state, MMIO base, memory mapped IO base, address, I guess, if supported. Memory base, 0 for default, A000. That sounds familiar. Window size, default, 64K. States to save. Frame buffer, depth, not important. Number of attribute controller registers, CRTC, graphics controller, sequencer. So this is interesting. This is looking familiar. Number of registers. I wonder why that's important, or what that corresponds to. Vid state is a pointer. A void pointer. All right, I'm not well versed enough in C to know why we would need a void pointer. Is it just a typeless pointer, maybe? So, save VGA, restore VGA. We pass the state. And generic port read write. I guess some of these are short enough just to implement right in the header file. So yeah, okay, lots of helper methods. And then if we get into the implementation, what do we have? Oh, I found this and thought it was awesome. There's a VGA save text method. So that might very well be what we need. Reg state. Where's that coming from? We're including VGA. There's a frame buffer header somewhere. All right, whatever. So we're declaring little 2-byte numbers for all of these. So we have attribute 1, 0, graphics 5, 6, sequence 1, 2, 4. I wonder if these are the bit numbers. Looks like it. So if in graphics mode, no need to save. That makes sense if you're already not in text mode. But what IO base, why are we still writing stuff? Why wouldn't it just return right then? But okay. So VGA read, VGA base address, IO base. What is this IO base thing? Oh, I see. I see. So this is the D versus B thing. This is the color versus mono thing right here. So that's where some of the IO addresses for, so it's checking. This corresponds right back into our code. So that's awesome. This would be, if you go into VGA and we go into external, this is right here. This is the IO address select. We're ANDing 1 to get that first bit of the miscellaneous register in the external general set of registers, and then selecting mono or color based on that result. So IO base is the exact same thing as IO address select. So that's 1 bit, and then, or no, I'm sorry, IO base is just a base address. So they're going to add 0xA to read something. Which one is 3DA? I wonder if I should fork this and like add comments to figure out what's going on. But 3BA is input status 1. So we're going to read input status 1 into the VGA base, I guess. And then we're going to write the attribute W. What is that? Attribute controller, data write register. Okay, so we're going to write to the attribute controller. I'm a little confused by this. VGA write port value. Don't we need to provide the index? Okay. Anyway, where are we populating this VGA base thing? State is passed in. So okay. All right. So I guess the assumption is we're already in text mode. So what are we doing here? Attribute, read attribute. So we're reading port 10 there, or index 10. What are we doing? We're saving registers. So we're saving read. What is this RGFX? RGFX. Graphics control register read write. So we provide the register base address and the register. And then we read, or I'm sorry, we write. Oh, I see. We write the address and then we read from the data port. How are we able to use? I think _I is address port. D is data port. So VGA read graphics. I see. So this is reading the GC in our parlance, graphics controller. So that's specifically for reading the graphics controller. So they have a similar approach. Good. So we're going to read from the graphics controller. Still don't know why. All right, we're reading the graphics controller into our VGA base state, but it returns it. Confusing, but okay. Plain read. What is this? Oh, okay, so that's one of the indices in the graphics controller. So we're checking the plane read, checking the mode, checking the MISC. So we're just going to read all these guys. So we read a bunch of registers. Okay, fine. We blank the screen. So we only are interested in saving 5 register values? Okay. We blank the screen. So we read from the sequencer the clock mode. We write to the sequencer the reset bit. We write to the sequencer the clock mode. We set the reset bit to 1, which I think if we set it to 0B11, like we're definitely having one of the resets enabled because there's 2 reset bits, right? So we're turning something off. Clock mode, sequencer value of the clock mode, ORed with 1 over 5. So we're setting bit 5 to 1 in the clock mode. What does that correspond to in the manual? It's a very big manual. So maybe not the best place to find this. Let's just go look in the sequencer in our code base here. Open up that OS. All right, so clock mode register, clocking mode register right here. Bit 5, it says SD, screen disable. So okay, so we are disabling the screen, which I guess makes things faster. Okay. So we blank the screen. We write to the sequencer reset 0x3. Okay, so for the reset, we're turning something off as well. Reset register, we're turning off. Synchronous reset is set to 0. So the sequencer halts. Asynchronous. Oh, so we're saying both of these tell it to halt. Wow, I bet setting both of these to 0 at the same time causes some big problems, which is probably what we were doing. So we say synchronously reset the sequencer. There's no wait, which is interesting. Maybe that's why it's a synchronous reset. Maybe it blocks somehow until it's done. We set the clock mode, which we set the screen disable. Okay, so this is looking a little clearer. Yeah, it blanks the screen. Got it. It blanks the screen, but first we have to turn off the sequencer and then re-enable it. Okay, fair. Save font at plane 2. If the flags contains VGA save font 0, so that's interesting. That's a nice little, so 1, 2, 4, 7, 8, 16. So these are all like 0B1, 0B10, 100. So like each of these are just 1 bit. So if the flag for save font 0 is set, we're going to write the sequencer. Okay, what are we doing here? We're saving the font at plane 0. Wow. Save the font at plane 3. Save font at plane 0/1. Restore registers. So we were doing a mem copy before. Maybe we just aren't doing enough of it. Maybe by default we should be saving all these fonts. So I think the solution to this will eventually be to use this code to basically put it in our own language here in the paradigm that we have in VGA enter and all that stuff. So restore registers, unblank screen. So I guess we blank the screen to save time. And then restore VGA text, save registers, blank screen. These conditionals are a little confusing. Restore the font. I wonder if that's where we're running into issues, is that the fonts are getting wiped. Restore the font, unblank the screen, restore registers. Okay. What are we doing when we're saving VGA mode? we are checking whether we're in color or mono, and then saving the CRTCs. Okay. Reading, we're writing to the attribute controller. Something. I don't know. A lot going on here, not a lot of comments. So those are two big ones. Save text and restore it, and save and restore VGA mode. And then what is this VGA CMap? Restore VGA CMap. VGA cleanup. Just cleans up some pointers and things. Save VGA. Okay, restore VGA. What is this? Just everything? Is this just a roll-up? VGA cleanup. Does it call the other sub-methods? VGA cleanup, VGA cleanup. Save VGA text. Yeah, so this is kind of like a main thing. Where does it call the other one? Save VGA CMap. Save VGA mode. VGA cleanup, IO remap. Okay. VGA cleanup, VGA cleanup, VGA cleanup. Save VGA text. And then restoring VGA. Restore VGA text, CMap, mode. Okay. So that's 500 lines of code basically. From this, can we figure out how to do what we need to do? Maybe. Let's start by just seeing where we're at with the Docker shell. If we run os.py, os.py run, oopsies, xhost plus, and then we can run os.py run, Python run, okay, there we go. And then, what else? Go into VGA mode, come back. So we're okay going in and coming out. Clear, VGA info, whatever. And go into VGA mode, come out. So, the question is, how do we, I think, let's just see the effects of following along with the Linux code here, if we do that in our code instead of what we're doing. So instead of doing all this stuff, I'm going to go out on a limb here and delete all this stuff. You know what? Might be good to keep some of this around, but I want it to be a little bit smaller for sure. We'll comment these for now. Get VGA, I don't need that. I'm going to get rid of this like top level state here that I have. Probably not the best. VGA info, whatever. So I'm not going to set any registers yet. I want to step by step, I want to see what it's like when we blank the screen and then unblank the screen. We'll start with that. So CRTC, sequencer, we'll have all these at the ready if we need them. Oh, we're not even doing the mem copy. Maybe that's part of the problem. Or no, that's just zeros. So we're not going to do any of this either. We're not doing any fancy drawing, nothing. Same for the exit. Let's pare this down quite a bit and take it easy. I don't need that or that. Looks nice. Graphics controller, pare that down too. And we will just take it easy, follow the Linux kernel, and be merry. Really glad the Linux kernel is open source. Imagine if it was not. We wouldn't even be able to look at this. We wouldn't be able to figure this out. It's amazing. Gotta love good old Linus. And the many other people who contributed to that code base. Okay, so So it does nothing now. All right. Good. That's what we want. We're back to doing nothing. Now, actually the approach of setting all these registers might be bad. So how would we do this in our code base? How do we do the clock thing where we blank the screen? Save regis. So instead of saving the regis, let's just start by blanking the screen. I want to see if we can do that and then unblank it. So in order to blank the screen, we need to get the sequencer clock mode. So we have access to that through this method. And then we write the reset. We set the reset to 1. So we don't want to be writing all of these at the same time. So we'll say set reg. Actually, we have a sequencer reg setter, don't we? Set sequencer, set seek, set reg seek. So let's use that. Set reg seek, sequencer. I might have to expose that. Let's expose both of these at the header level, because we don't want to set the whole sequencer anymore. That was too heavy-handed. So we can set reg sequencer, and we're going to use sequencer clock mode. And what's the other argument? The index and the value, we want to set it to a 1, which should turn off the sequencer. We're not going to use that set seek at all. And then we are going to synchronously stop the sequencer. Then we're going to clock mode to, and what is it again? Bit 5. Turn on the screen disable bit. Set reg seek. VGA seek reg. Was it the clocking one as well? Clock mode. Oh, this is wrong. This should be VGA sequencer reset. Reset register to 1. We set the clocking register to whatever the clock mode already is, dot reg clocking, but we OR in, I'm going to use parentheses because I'm not that sure of my order of operations, the 5th bit, right? If we left shift 0, if we left shift 1, 2, 3, 4, 5, yes. So that's got to be it. Set the screen disable bit, and then we will turn off the reset bit, sync reset bit. And so that's going to be 0B11 or 0x3. So both of those bits will be enabled. And let's see what that does. So this should disable the screen. So let's see if it blanks out. Maybe I've been, I forget a semicolon. I did. Okay, VGA. Doesn't seem to do anything. What the heck? Okay. What if I don't turn this sync reset back on? Does it? Doesn't really do anything either. Interesting. It's not what I expected at all. But what else is new? VGA just doesn't seem to do what I think basically ever. Okay, blank screen. And what else we got? Save font at plane 2. blank the screen. We blank the screen and we basically save off a bunch of stuff. So saved, what is this saved thing? Saved is vid state. What are you doing? Vid state, is this just like a really big VGA state? Vid state. It's a void pointer. Alright, I need help. Help me, ChatGPT. What is... Please, briefly, explain the purpose of a void pointer in C. Because I have no idea. Any data type. Seems risky. Void pointer. And so what is the state actually pointing to? Video state. Vid state. That is a different header, right? Video mode maybe? Or did it say in there what that was? Oh, it's casting it to reg state. Where is struct reg state defined? Oh, here it is. Oh, it's in this file. So, what is this double underscore U8? Serious? Okay. Oh, it's a pointer to unsigned 8-bit integers. So it could be any length. That's a little scary. Font 0, font 1. C map, character map. So maybe I'm not saving the right data off when I do this. What else did we have to reference? I want to go look at that too. Let's look at the BIOS thing. This has been very helpful though, the Linux kernel. What's this Open BIOS thing doing? So it's outing to the miscellaneous synchronous reset on, sets everything to zeros. So it's just putting it in reset mode. Write the sequencer memory, guys. Blank display. Reset off. Okay. Oh, I see. The address is 0, the value is 0, the address is 0, the value is 3, so it's not reset anymore. Deprotect. Okay. IC is color mode, CRT. Maybe my problem is using the color mode, or not using the color mode. I think I was using mono by default. But I don't know. Write the CRTC registers, write graphics, write attribute, initialize the color table, palette mask, turn on video, disable palette access. Interesting. This is pretty nice. Red, green, blue. What else are we doing in here? Decode var. VGA settings. Diagrams. From the Linux kernel code base. So everybody's pilfering the Linux kernel. I guess I don't feel so bad. The question is, what part of the code base, or did it change a lot? Okay. This is interesting. So I guess we can go back to just playing around with this code and see what happens. So before, the big difference seemed to be changing certain things about the sequencer. And I'm wondering if we can just do something similar. So it's actually pretty helpful that they include the order in which they're doing these things, because I think that's probably very important, is what order we're using. And another angle is the I'm sorry, I'm lost in train of thought. Another thing is saving certain things in memory. So we disable the screen, right? Blank display. Xerox20, Xerox20. Is that the same as 1 left shifted 5 times? $32. That is Xerox20. Okay, so they're doing the exact same thing here. For register 1, which is the reset register, right? Yes. No. Maybe. Reset register is 0. They're setting the clocking mode. Hold on. No. This turns the sequencer off, and then they're going to 1, which is the clocking. That makes sense. Okay, and then they're writing to the data for, sorry, I'm just getting used to how this is done. Same thing, but what is this for loop for? For I equals 2 to sequencer C, output I, to the address, output the value to the data. So I think it's just iterating whatever, what I guess what type is that? Sequencer, what is this par? VGA par. Struct VGA par. Where is this defined? Okay. Anyway. Well, let's see what this does anyway. So they're doing the same thing anyway. Synchronous reset off, and that's where we left off in our code. So after we do that, what are we going to do? Write to OX11 for the CRTC. So let's decode what that's doing. I can't believe this stuff is like so opaque. How are there not comments in this code? How do people know what they're even doing? So 0x11 is the vertical retrace end. No. Is that right? So we're writing that as our address register for the CRT color mode. Yes. Okay. And then we are putting our value out of our little struct there into the data. So, okay. Then we're just looping through the CRT registers, looping through the graphics control registers, looping through the tribute control registers. Initialize color table. Turn on video, disable palette access. What's going on here? We read from IS1 RC. That's a delay. Interesting. I don't like the input from 0x80 because isn't that a kernel call? So it might be relying on something else. ATTIW. So we're writing to the attribute address 0x20. Attribute controller address 20. I don't see anything for that. And this is important, so it would be good to understand. It says it's very important. What is this ATTIW? Where is the VGA.h? So is this where we get that definition of the screen info par? So it's CRTC. Oh, this is the count. CRTC is the count of registers. Nice. Okay. So that's a pretty straightforward way of defining it. VSS, I don't know what that is. ATTIW. Attribute controller, index, and data write register. Is that the case? Are they combined because they're right next to each other? Maybe that's, they're writing two thingies to it. That's confusing though. All right, I'm not really sure what's happening here. So, well, what were we doing before to get that effect? Let's see if we can't make something happen again. Just so we'll get the graphics controller values. I mean, the old way of doing this worked. So let's go back to that and see if we can step our way yet again, but with a little bit more precision this time towards getting this done. So the old way of doing this was we set that. So I'm going to actually do that the same way again. So we get the graphics controller, and then we're going to set, let's expose those graphics controller methods just the way we did with the other one. Set reggc, get reggc. We don't want to set the whole thing, we just want to set one register within the GC. Okay, so set reggc, we're going to set the miscellaneous reg and we're going to give it a value of the existing value, reg mis, ORed with 1. Alphanumeric disable, set it to 1. Set alphanumeric disable to 1. Turn off text mode. So that can be these three. Okay. Let's see what that does. In theory, that should change the screen. Yep, it does. Escape does not put us back. However, I think we can take a similar approach to, I don't know why we're setting the screen disable bit, but I guess we can do that again. See if it works. Maybe there's some kind of synchronous thing going on that's messing things up. I don't know. But we can AND it with 1 when going in the other direction to re-enable alphanumeric mode. turn on text mode, I think, would be the effect. So let's do that again. VGA. Ah, we're back. But I lost my text output. Clear, clear, clear. Something's not right when we go back already. Something is not right. So something didn't get saved, or I don't know what happened. What if I don't restore video memory? Then is it a black screen? No. Seems to restore. It's weird because the prompt is printing, but I can't type anything. Why is that? Did the font get messed up? I wonder how we fix that. I guess we can think about where the fonts are. And I guess if we boil that down, it's really just areas of memory that we have to save off somewhere and restore. So I just did it to 10B8000. What else was the Linux kernel saving off? VGA read, frame buffer, base, I. What is this frame buffer base variable? FB. F base. Where is that? Oh, it's passed into the method. It's a memory address. Okay. Okay, so how do we know what that is? I guess the main method was somewhere, right? It's at the bottom down here. FBase, so it's calculating IO remap, membase, memsize. What does that even mean? Gives you a, oh, is this IO remap just doing a copy of some sort? And then passing back a base memory address? Remap, unmap. Save VGA. So it's like allocating memory, which we can't really do yet. We just have to guess at which pieces of memory are used and which aren't, which is not ideal. Is there more to be found out about, maybe ChatGPT knows something. Can you explain where and how VGA fonts and character sets are stored in memory? It's a long shot, but let's see. This did not help. All right, that was maybe silly for me to ask. Let's go over to the VGA docs and it's got to tell us about this somewhere, right? This guy really overwrote this. Was pretty helpful. But I think this is stuff that we've already done. Mm. Okay. So in interrupt routines, you don't want to interrupt and mess up the value. That makes sense that these would all be changing. Yeah, interrupt routines. Okay. Okay, so address register. Oh, yeah, but we are restoring the address registers in our setReg methods, right? I'm pretty sure. Where's our generic setReg? Yes, saved address reg. We grab it, we output to it. Yeah, so we're doing good practice there. And the sentence kind of just ended there. Okay. Attribute registers, indexed fashion. Whoa. So I have to do this whole thing to read and write the attribute registers? Oh, man. I don't think we have to worry about interrupts. Well, we do, because we have the kernel.c with the keyboard interrupts, which all of this stuff might actually be running in an interrupt routine, which is not good. Color registers. 3 bytes to store. Okay, so we have a color palette, and I'm assuming there's like a font or something. Maybe I just have to go back to square one and read all this stuff. Okay, this would all be good to know. Accessing The display memory. Hardware has onboard display memory. Okay. But it's not directly available. 128K in the high memory area. Ooh, linear frame buffer. Okay. Okay, I think I need to read all of these and then come back and do a new stream where I actually know what I'm talking about. So yet again, I've been vanquished by VGA, but I'll live to fight another day. Let's see what we can commit, if anything. What did we do? Added some notes. Good enough. All right, so that's it. Yeah, if you're watching still somehow, like and subscribe, support this, and eventually maybe one of these streams will get this working, and I can make a video about all this stuff and sum it up in short. But until then, thank you for watching. Talk to you later.